Hey, this is Mathcamp321 bringing you your second installment on limits. This particular video is on finding limits using direct substitution. So in our first video sequence, we looked at analyzing limits through a graphic lens. And in this video, let's suppose that we don't have a graph. So we might have to find the answer to such a limit question by using what's called direct substitution. That is to say, simply plug in the given x value into the function. Note, if your substitution yields a fraction 0 over 0, you have to try something else. So let's take a look at our first example. Find the limit of secant of x as x approaches pi over 4. So some cases we don't have a graph, but we can sketch one. In other cases, we have a function and the graph is just too hard to come up with. The first thing you should always consider doing in a limit question is just plugging in the x value in for x to see if you get an answer. If you actually get an answer and it's not 0 over 0, then you're good to go. So for this first question, I'm just going to simply evaluate the secant of pi over 4. Now, the secant of pi over 4 is actually pretty easy if you're familiar with your trig tables and your unit circle. So I know that the cosine of pi over 4 is root 2 over 2, and that cosine and secant are reciprocals of each other. So if the one is root 2 over 2, the reciprocal of that is just root 2. In our second question, we're asked to find the limit of the natural log of x squared as x approaches e to the fifth. So what I'm going to do here is just write the natural log, and I'm going to put a blank squared, and in for the blank I'm going to put in what x was, and x was going towards e to the fifth. Using rules of exponents, I know that raising a power to a power means I'm going to multiply, so this becomes ln of e to the 10th. And then remembering that whenever we use natural log, there is an implied base of e. And this can be interpreted in the following way. E to some power equals e to the 10th. So this all equals something, and I can say that this is the same as e to the x. E to some power is equal to e to the 10th. So the answer here is 10. So again, what we simply did is we just plugged in what was given for x into the x value in the function and got the answer that way. And again, the only time this isn't going to work successfully is when you plug in and you end up getting 0 over 0. That's when you have to try something else, which we'll address in future videos. Okay, in problem number 3, they ask us to find the limit of 10 as x approaches negative 3. Now, having some experience with limits, this is actually a very easy question, but when you're first learning, it's so easy that it's actually kind of tricky. So what I'd like you to do for this particular problem is I want you to think of 10 as a function. So I want you to think of this value here as a graph. I want you to think of it as y equals 10. And y equals 10 is just a horizontal line going through 10. So what I think I'll do real quick is just draw a set of axes here. Okay, so we've got the y-axis, we've got the x-axis, and now what I think I'm going to do is I'm going to put in the line y equals 10, which I'll put up here. And what I'm going to look at, I'm going to go back to the graphic perspective from the first lesson, which is to look at this x value at negative 3, which might be maybe over here, and then project up, and jump to the left and approach, and jump to the right and approach, and ask yourself, what y value am I approaching from the left? What y value am I approaching from the right? And as you may have guessed, the answer is 10. So what's unusual in this particular problem is that the function just 10. There's nowhere to plug in that negative 3. So students are sometimes very confused. What do I do with the negative 3? There's nowhere to plug it in. But if you switch back to this first video that we did on the graphic analysis, then it makes more sense. So the answer is just 10. Okay, for our final example, we're asked to find the limit of this sort of big rational function as x approaches 1. So I'm just going to start by plugging in 1 and seeing what happens. If I plug in 1 and I don't get the fraction 0 over 0, then I'm good to go and I'm done. So let's start with the top left. If I plug in 1 for this x right here, I get 2 times 1, which is 2, and 2 plus 3 is 5. Now when I plug in 1 over here, I get 1 minus 2, which is negative 1. And going to the denominator, plugging in 1 here, 1 squared of course is 1. And then I'm going to add to that another substitution, which would be 1. And then the trinomial ends with another plus 1. So in the end, we end up getting negative 5 over 3, negative 5/3. It's not 0 over 0. It's a perfectly reasonable answer. So the answer to this last question is negative 5/3. So this video addresses the technique of solving a limit question using direct substitution. It should always be something you consider doing first, because if it works, you're done and there's nothing left to do. In subsequent videos that I'm going to make, we're going to see cases where when you do plug in, you get 0 over 0 and how to handle those situations.